Hey there, sixth grade. In the last video, we learned about what a proportion is and how to write proportions. In this video, we're going to look at how to solve proportions. So imagine this scenario here. We have two stacks of Jenga blocks. Okay, if you've ever played Jenga, then hopefully you know what I'm talking about here. This tall stack of Jenga blocks, it says, is 25.8 centimeters tall. And Jenga blocks are all identical, okay, the individual blocks, so each of them have the same length. So the length of this stack here is equivalent to the length of this stack. Using that information, the question's asking how tall is the shorter stack of blocks. Okay, and that's something that if we wanted to find that answer, we could set up and solve a proportion. So a proportion, remember, is just an equation that states that two ratios are equivalent. And for those two ratios, the product of the numerator in one ratio and the denominator in the other ratio is called a cross product. And the way you can tell whether or not two ratios are equivalent or proportional is if the cross products of those ratios are equal. Okay, it's a quick way to tell whether or not you have proportional ratios. So let me show you what I mean by this example here. We have the ratio 2 to 5 and then the ratio 6 to 15. To verify that these ratios are equivalent, I can take the cross product of the numerator of my first ratio and the denominator of my second ratio, and that would just be 2 times 15. 2 times 15 is equal to 30. So I get 30 for this cross product, and then I can take the cross product of my other numerator and my other denominator. That would be 5 times 6. 5 times 6 is also 30. Because these two cross products are equal to each other, 30 and 30, that means that these ratios are proportional. And so we're going to use this little fact here to set up and solve proportions that have variables in them. So this will be our first experience in sixth grade solving equations with variables. I know you did this a little bit in fifth grade last year, not necessarily proportions, but solving equations for variables, and we're going to start that process here. So example 1, we have the proportion p over 6 equals 10 over 3. Okay, so in an equation, I want to solve for my variable, my unknown. So in this case, we're solving for the variable p, and we're going to use cross products to do that because this is a proportion. So the way this works is I'm going to multiply this numerator times this denominator. Okay, just think about a diagonal. So that's going to be p times 3, or we could also write that as 3p. Okay, 3p means 3 times the variable. I'm also going to multiply my numerator 10 times my denominator 6, so my other diagonal. 6 times 10 is 60. So I get 3p for one, 60 for the other, and I'm going to set these equal to each other because in order for this to be a true proportion, this cross product, 3 times p, has to be equal to this cross product of 6 times 10. So I have the equation 3p equals 60. To solve for p, because this is multiplication here, I need to undo my multiplication with the opposite of multiplication, and that would be division. So I'm going to divide the left side of this equation by 3 in order to undo this multiplication, and I'm also going to divide the right side by 3. When you're dividing, show your division with a fraction bar. When you're solving proportions, show them with a fraction bar. So 3 divided by 3 here on the left side is just 1. So these 3's you can think of as just canceling each other out, and you're just left with the variable p. On the right side, 60 divided by 3 is 20, and so we get an answer of p equals 20. So what that means is, in my original proportion, I can replace the variable p with the solution, the number 20, which is my answer. And if I checked these cross products, they should be equal to each other now. 20 times 3 is 60, and 6 times 10 is still 60. Okay, so this is a way to check our answer here, but P equals 20 is your answer. Okay, number 2, 16 over 4 equals 8 over x. Again, I'm going to take the cross product of my first diagonal. That would be 16 times x, or 16x, and then the cross product of my second diagonal, 4 times 8, which is 32, and I have 16x equals 32 now for my equation. Next, I'm going to divide both sides of this equation by 16, and that undoes my multiplication here on the left side. 16 divided by 16 is 1, so I'm just left with x. And then 32 divided by 16 is 2. So I get x equals 2 as my answer here. Again, you can check that by taking your original proportion, 16 over 4 equals 8 over, replace x with 2 now, and these cross products should be equal to each other. 16 times 2 is 32. 4 times 8 is also 32. Number 3, we have 5.5 over 6 equals 16.5 over w. So I can take the cross product of this first diagonal, that would be 5.5w. And then the cross product of my second diagonal, which is 6 times 16.5. So I have to do a little bit of scratch work for this multiplication because it involves a 3-digit number and decimals. 16.5 times 5, or times 6, excuse me, should be 99.0. Okay, 99.0, or just 99. So I get 5.5w equals 99. From there, I can divide both the left side and the right side of my equation by 5.5. So 5.5 divided by itself will cancel my 5.5s out on the left side, so I get w equals, now I need to set up over here a long division problem. 99 divided by 5.5. This is decimal division, so we need to move our decimal point in the divisor one place to the right to make this 55, and then in our dividend, here's my decimal. I need to move it one place to the right as well, add a 0, and so in my quotient, my decimal point will be here. 55 will go into 99 one whole time. So I multiply, subtract, and I get 44 left over. I can bring down this 0 now. 55 will go into 448 whole times. 55 times 8 is exactly 440. So you get a whole number for your answer here, and that whole number is 18. So w equals 18. Okay, on the back side we have one word problem, and this goes back to the situation we were talking about in the beginning. So a stack of 18 Jenga blocks is about 25.8 centimeters tall. What is the height to the nearest tenth of a centimeter of a stack of 11 Jenga blocks? Okay, so what we're going to do is we're going to compare this ratio here. We know there are 18 Jenga blocks compared to 25.8 centimeters. So that's the ratio 18.2 to 25.8. And now we know in the smaller stack there are 11 blocks. So that would be 11 blocks. 2, we don't know the height of the second stack. Okay, it's asking what is the height. So what I can do is I can put a variable in the denominator. Okay, for instance, I could put an h in the denominator to stand for height and set up a proportion to figure out what's the height of my smaller stack. So we have 18 to 25.8, and we're going to set that equal to 11 to h. And what this proportion is going to do is, once we solve this, allow us to find what's the height of that smaller stack. So now I can solve this proportion using my cross products. So I'm going to take 18 times h for my first diagonal, and then 11 times 25.8 for my second diagonal. Set up some scratch work here to do 25.8 times 11. These problems will be some good review for how you multiply and divide decimals. And so for that you should get 28,283, which is going to become 283.8. Remember, one decimal place here. So we get 18h is equal to 283.8. And now to solve for this variable h, I need to divide the left side and the right side of the equation by 18. So to find h, we're going to do long division 283.8 divided by 18. So my decimal point is going to go here in my quotient, and now this is where directions become important. It asks for the height to the nearest tenth. So if I'm rounding my answer to the nearest tenth, that means I only need to go to the nearest hundredth, so 2 decimal places in this long division. So remember that. 18 will go into 28 one whole time. I multiply, subtract, and I get 10. I can bring down my 3 now. 18 will go into 103 5 whole times. And 18 times 5 is 90. So I subtract that from my 103, and I get 13. Bring down my 8 here. 18 will go into 138 7 whole times. 18 times 7 is 126. So subtract that, and we just need to go one more decimal place now so that we can round correctly. So we'll do 18 into 120, and 18 will go into 126 whole times. Okay, from there we're done, because all we need is we needed this 6 here so that we know this 7 needs to round up. So our answer becomes 15.8, approximately 15.8. So let's write this in a sentence. Since it's a word problem, we can say the height is approximately 15.8 centimeters. Okay, so if you had any questions 6th grade over this video, make sure you ask those the next time you're in class. Until then, have a nice day. You're all wonderful people.